So we have f of x. And so we say that as f of x, which actually means the function that uses the variable x. So if we change the function notation a little bit and we say f of a, this would be the function that uses the variable a. But that's not all we can do with this notation. We can even change the f of to a different letter as well. So f is a function. G is still a function as well. So this is still a function, but this one will be a function that uses the variable y. So usually when you see f of x and then later you'll see g of x, it really shows that they're different functions. Okay? So the function notation might seem a little bit new to us, but it's actually not that scary once we can get comfortable with what it means. To the function g of a is equal to negative 2a minus 12. What this means is when we're splitting our function in half, when we insert the a here, we replace every single a in our equation or our function with that number. Therefore, g of 3 means replace a with 3 and see what your output ends up being. So our function is negative 2a minus 12. So I do negative 2 times 3 minus 12. So negative 2 times 3 is negative 6 minus 12 is equal to negative 18. Therefore, we would write our answer as g of 3 is equal to negative 18. Or we could write it as the ordered pair 3 comma negative 18. G of 6 is the exact same idea. We replace our x with, or our a in this case, with 6. So I do negative 2 times 6 minus 12, which gives me negative 12 minus 12, which is negative 24. Therefore, g of 6 is equal to negative 24. Or we could write it as the ordered pair 6 comma negative 24. Let's do one more. G of 1/2. So once again, we're using a fraction here. So I would say negative 2 times 1/2 minus 12. 1/2 of negative 2 is negative 1. Minus 12 more gives us negative 13. So I will say g of 1/2 is equal to negative 13. Whoops, I clicked my mouse there. Or we could write as the ordered pair 1/2 comma negative 13. We can also write it as an equation. Now in this equation we have two variables. We have x and we have c. And if you notice down here, we are picking the c and finding the x. And you can do that in either order. Most of the time, whatever variable has more numbers next to it will be what you're using as your input. But you can use either one. So let's find each of these answers. So when c is 12, we are going to substitute 12 in for each c. So I will get x equals 12 sixths, or 12 divided by 6, plus 4. 12 divided by 6 is 2. 2 plus 4, whoops, is 6. Therefore, when c is 12, x is 6. Well, when c is negative 6, it's going to be the exact same idea. We're going to say x is equal to negative 6 this time, divided by 6 plus 4. Negative 6 divided by 6 is negative 1, plus 4 is equal to 3. So that means c is equal to 3. Now down here on the bottom, we have two more examples. When c is a positive 6, I will say x is equal to 6 divided by 6 plus 4. That's 1 plus 4. And x equals 5. And finally, x is equal to negative 3 sixths plus 4. Uh-oh, this is not a whole number answer, which means our answer needs to be either as a fraction or a decimal. Personally, as an 8th grade algebra student, fractions are going to be easier most of the time. So I want to simplify 3/6 to negative 1/2 plus 4. So I want to take away 1/2 of 4, which means that x is equal to positive 3.5. Now, before we move on to our next topic, I want to showcase one small thing that's going to come up a ton in high school math. It won't be a huge focus in algebra, but it will show up a ton in Algebra 2 and geometry, which is the idea that your function and your equation notation are interchangeable. So on the top, I have the function that uses x is equal to 1/2 of x plus 3. But I can also write it as y equals 1/2 x plus 3, which is why you will see many teachers at some point in your life will say that f of x and y, when they have equal to, are the same thing. I frequently just say, this is function notation, this is equation notation. And you can absolutely find inputs and outputs with either one, and they will absolutely work both ways. As always, if you have any questions, please let me know.